Today we will be simplifying radicals. So let's take a look at what we know. What is the square root of 4 times the square root of 9? Well, the square root of 4 is 2. The square root of 9 is 3. So 2 times 3 equals 6. How about the square root of 36? Well, we know that's a perfect square, so that equals 6. So how are these two problems related? Well, if you take a look, the answers are the same. So these problems are equivalent. So if you look back at what we started with, the square root of 4 times the square root of 9. What does that tell you about the relationship between this problem and this problem? Well, there's a property of radicals that says for every number, if a is greater than or equal to 0 and b is greater than or equal to 0, then the square root of a times the square root of b equals the square root of a times b. So in words, the product of the square roots is equal to the square root of the product. So even in more simple terms, if you have numbers written under the radical, you're able to multiply the numbers together. So let's take a look at an example. The square root of 25 times the square root of 4. Well, they're both underneath the radical symbol, so I can rewrite that as the square root of 25 times 4, which is the square root of 100. Now, I also could have recognized that they were both perfect squares. So I could have written that as the square root of 25, which is 5, times the square root of 4, which is 2. But as you'll note, either way, both of those equal 10. So let's look at example 2. The square root of 16 times the square root of 9. Well, I can multiply 16 times 9. 16 times 9. And get the square root of 144. Or again, we memorized the first 20 perfect squares. I should have recognized that 16 and 9 were both perfect squares. So the square root of 16 is 4, and the square root of 9 is 3. What is the square root of 144? We know that's 12, or 4 times 3 is 12. They're equivalent. One more example. The square root of 49 times the square root of 5. Well, 49 times 5, since they're both underneath the radical symbol, I can multiply. And I get 245. Or, let's take a look. Are they both perfect squares? Well, the square root of 49 is a perfect square. We know that's equivalent to 7. The square root of 5, not a perfect square. So I'm just going to have to leave that as the square root of 5. Now, do these two have the same value as we did in the other examples? Well, you can check it on your calculator, but yes, they do. So, let's go over some vocabulary. When we're simplifying radicals, the radicand is the quantity or expression under the radical sign, and simplest radical form is a radical that is in its simplest form if the radicand has no perfect square factors. So Now we're going to reverse the process from above and write the radicand as a product of two numbers. If one or both of these numbers is a perfect square, then the radical can be simplified. So this is where the reason that we memorize the first 20 perfect squares is because these are problems of recognition. You have to recognize perfect square factors. So I gave you a list of the first 15. We memorized up through the first 20. Okay, so example 1, the square root of 900. So what we're trying to do now is reverse the process. Can you think of two factors of 900, one or both, which are perfect squares? So take a look at your perfect squares. Do you see one? Maybe 9? Is 9 a factor of 900? 9 times 100 equals 900. So I can rewrite the number 900 as 9 times 100. Again, working backwards from the property on the first page, I can break this down as the square root of 9 times the square root of 100, because we learned that if I multiply two numbers under the radical, I end up with this, so I'm just working backwards. So the square root of 9 is 3, the square root of 100 is 10, and 3 times 10 is 30. So in that case, both of the factors were perfect squares. But sometimes only one factor will be a perfect square. So let's look at example 2, the square root of 12. Think about the factors of 12. And again, if you need to list your perfect squares, it's not a bad idea, because these are the numbers you need to think of as possible factors of 12. So I think I see one right here. The square root of 4 times the square root of 3 would give me the square root of 12. So the square root of 4 times the square root of 3. Again, they're both underneath the radical symbol, so I can write them as separate radicals. The square root of 4 is 2. The square root of 3, that's not a perfect square. So in simplified form, I don't want to round, I don't want to estimate, I want to leave it as what it is. So the simplest form of this number would be 2 radical 3. Example 3, the square root of 48. Again, go up to your perfect squares. Do you see any factors that are perfect squares? I see 4. I also see 16, which I know. And if you didn't know 16, I'll do it both ways. 16 times 3 is 48. So since I knew that, I can simplify. The square root of 16 is 4. The square root of 3 can't be simplified. Now, had I recognized the square root of 4 and the square root of 12, let's see what would have happened. 4 times 12 is 48, so I can write these two. The square root of 4 is 2, but the square root of 12 still has a perfect square in it. We recognize that from problem example 2. So I'm going to have to rewrite the square root of 12 as the square root of 4 times the square root of 3, and I'll bring this one down. So sometimes if you choose too small of a perfect square, you may have to do the step 2 times. So the square root of 4 is 2. The square root of 4 again is 2. And then I have radical 3. 2 times 2 is 4 times radical 3. But as you notice, that's the same answer I got when I use 16 and 3 as factors. So it really doesn't matter which perfect square you choose. You may have to do an extra step if you choose too small of a perfect square. Okay, if there are no perfect square factors, then the radical cannot be simplified anymore. So if you look at the square root of 30, if I go back up to my perfect square list, 1, 4, 9, 16, 25, okay, I can't go any bigger than 30. None of those are factors of 30. Well, one is, but it's not going to help me. So then radical 30 is it. It can't be simplified anymore. So you just leave it as radical 30. So I want you to take a few minutes and try the rest of the problems with your group, and then hit the video again and check your answers.